All right, this is it. This is the last of our 5 videos on the Macrosim economic simulation models. We finally have built Macrosim 2, so let's start to use it for something. Let's run some Macrosim 2 trials. Now this video will be a little bit longer than some of the others because we're going to try to do a lot here. Okay, now this is Macrosim 2 in Python. And this is the default. Let's make sure we understand the default. And also you can, of course, again, look at the model itself. The link is in the first video. It's also on the page, one of the class pages, the text page for the class. Now, we see here, these are the values we assumed in the previous video that I cut. We have, you don't know what these mean, but they're represented over here. So we have autonomous consumption at 100, investment coefficient, consumption coefficient, at 75. Then we have the intercept and slope, savings, intercept, and slope, the same things we talked about in the prior video. And we have our policy variables separated, and these are our default simulation results. These here, by the way, are the solution to the big model. I'm certainly not going to go through that. It took me a long time to get this right. We had to satisfy the identity condition at the bottom of the model. So I actually have it broken down into an X1, X2 component because there's so many variables at work. But the algebra finally results in all of this. And this model is now ready to run, and this is the default. Now, the thing that is interesting about this is I set this up. It took a long time to do it so that the default values are the same as the values in Macrosim 1. So let's compare that to make sure that's true. So this was Macrosim 1, and GDP was 2,800. That's still true here. Income 2,240, still true here. Consumption 1,780. Taxes collected the same, the budget deficit the same. Now savings is different here because in Macrosim 2, savings is turned into the supply of funds, which is the same as savings was before. We didn't have any money supply in Macrosim 1, and that's why that's different. So basically we have the same model, and using, in other words, these investment intercept, slope, savings intercept, and slope up here gave us this solution, and that took quite a bit of time for trial and error. I also had to get results for this model where the elasticities for the savings and investment were realistic, and it turns out that they are at about 0.5. So, okay, when we run the simulation, it's very similar to the simulation we run in Macrosim 1. So let's get into this. First, let's pose some questions. Now, if we increase government spending by 10, what happens to the budget deficit? But also, what happens to the interest rate and the level of investment? Is this model going to show us crowding out? If we cut the tax rate from 0.2 to 0.18, as we did in Macrosim 1, and that generated a very robust response, what will be the effect upon national output or GDP? Tax collections, the deficit, the interest rate, and the level of investment. We couldn't deal with the deficit, the interest rate, and the level of investment in Macrosim 1. They didn't exist. Then what happens if we increase the money supply? And then we can combine some things. What happens if we decrease taxes, increase government spending, and increase the money supply all at the same time? What kind of effect do we get? So let's explore this and investigate these one by one. Now you may be saying, where is the multiplier in this? Well, in Macrosim 2, the algebraic multiplier does not fall out. You can calculate the multiplier by, and it still exists, but it's going to be different for every simulation because, again, it's no longer algebraic. It's going to be the case that you will get a multiplier effect in that when you increase autonomous spending, the level of national income will rise by more than that, but not as strongly as it did with the multiplier. And the way you have to calculate the multiplier is take the result of the increase in GDP and divide it into the increase in the autonomous spending category. You'll get a number like 2.1 or 2.2 or something like that. I don't do that in the model. I perhaps should have added that to the model. All right, let's go to the model itself now. And here we are increasing government spending by 10%. similar to what we did in Macrosim 1. Now, this is the default before we do that, just to make sure that we have that. Here's government spending at 600, GDP is 2,800, interest rate is 4%, and investment was 420. Now, you remember when we did this in the loanable funds model, we had a little bit of crowding out. Let's see if we're going to get a little bit of crowding out now that we've added that model to Macrosim 1. And we can see, yep, we're going to get some crowding out here. Here we increase government spending by 10% from 600 to 660. We do have a pop in GDP that's sizable, 2,800 to 2,909.09. But we have interest rates rising. Now, they rise by a little bit differently than they did in the loanable funds model. They rise 36 basis points. And as a result, we have a pretty substantial decline in investment from 420, the default assumption, to 403. And that's perfectly consistent with what we would see with the loanable funds model in effect. And it's the loanable funds model in this that's generating that. So we do have the desired level of increase in GDP, but we do have crowding out, and so all of the gain here is coming from consumption for the largest part. Well, we don't want crowding out, so we have now introduced the possibility of that. So let's run another trial, and this is, we're not continuing on, we're going backwards now, going back to, oh, let's see, that's not quite right, is it? No. We're not going backwards. Trial 2 is what we just finished. Sorry, this is not default. We have still increased government spending from 600 to 660, so we still have the crowding out effect. This is now our starting point, and that's from, of course, the last trial we did. So now we're going to cut taxes at the same time, and so we cut the tax rate 0.2 to 0.18, 20% to 18%. Now we have an additional pop in GDP, so this is very stimulating to GDP, but now the interest rate has risen another 50 or so basis points, a little bit less than that, and now investment has really been clobbered. It has dropped from its original value of 420, I think it was, to 383.4, and therefore we are looking at even more crowding out. And so this tends to show that if, just like the loanable funds model suggests, that if you simply increase government spending and cut the tax rate as a policy stimulus, it would stimulate the economy, but the rising interest rate would have some effect upon investment, and it may have a considerable effect upon investment. So we know from the loanable funds models, though, there is a panacea for this. We could accommodate that, as we learned when we used the loanable funds model, by increasing the money supply at the same time for a sort of super stimulus. Now, once again, we are back to, we're not back at the default. We are actually continuing the simulation. Government spending is still 660, but now the tax rate is 18%, and investment has been crowded out. So the next thing we want to do is increase the money supply like we did in the loanable funds model. So let's do that. So we have all kinds of things going on here now. So the money supply growth rate, the credit growth rate, we put at 11%, government spending at 660, and the tax rate at 18. Now that's a sizable increase in the money supply growth rate. And the result here is that we really have a strongly stimulated economy. This is a bit unrealistic compared to the U.S. economy, although maybe not. We're actually increasing, we're reducing taxes a lot more than has ever been done in a single policy move, so maybe this would be strong. But GDP is all the way up above 3,070. And look at this, the interest rate has actually come to 4 and dropped below it. So now we have a 4 basis points below the 4% that was the original default rate. So investment is actually a little bit higher now. And the budget deficit isn't quite as large as it was. And of course, this is all because we are really stimulating the economy now with an increase in the money supply. And that has stimulated disposable income, consumption has risen considerably. Investment is now also a little bit higher, and that's because the interest rate is a little bit lower. And so we have achieved a policy panacea. No crowding out, and everything is up. And as you say, well, isn't that kind of the current economy? Don't you keep saying that about the economy, the U.S. economy in 2018, actually 2017, 18, and 19? And yep, that's right. We're using all three of these policies currently. And of course, interest rates are at very low levels. You can use this simulation model to play around with, obviously, and you can obviously get that kind of result when you have control of the nation's money and credit supply. We have seen it before, remember? We pointed out that these kinds of stimulus packages do stimulate the economy, as we saw in the aggregate supply, aggregate demand model. Remember, we said that if you stimulate through a combination of the money supply and fiscal policy, there'll be a shift out in the aggregate demand curve. In this example shown here, this is moving it into the inflationary region. We're certainly not doing that in this current economy, at least not yet. It's more like we're shifting from right about here to where AD1 is in the current economy, because we fell back so far in the last recession, and also the economy's been expanding kind of slowly, expanding, but not expanding very fast. But we also know that we are running a stimulus package, or the Federal Reserve is running a stimulus package, and that in the context of the loanable funds model in the chapter, the comparative statics version of it, and even the simulation version of it, actually is capable of pushing interest rates down from R1 to R2, as is shown here. And if we stimulate even more than this by moving out the supply of funds line, you can get the interest rate down very low, which is actually what's happening in this economy. So we can run large budget deficits, really large budget deficits, and you can see a decrease in the interest rate from R1 to R2 if you increase the supply of funds enough. And the simulation model confirms with the feedback effects and all that that's exactly what you would expect in a real economy if that model has any integrity at all. And even though it's linear, it does have some integrity. It's capturing at least the essence of how this economy works. Now, I'm not going to show this. If you want to play around with the model, then you can do that, because the results we get in this depend in every way upon the sensitivity of savings and the interest rate, and investment and the interest rate, and that is also referred to as the elasticity. That's a concept from microeconomic theory. And so generally, for example, on the savings function, when it's flat like this, actually the elasticity changes at every point along a linear function. But anyway, even if you make it more steep like this, then inelastic sensitivity means you have a low sensitivity of savings to the interest rate. I'll just put here as a comment that if you run some simulations and make the sensitivity very inelastic, as is shown here, then the degree of crowding out becomes much more pronounced than it does in our model that we're using. And savings is regarded as fairly inelastic relative to interest rates in the U.S. economy right now. So we may be getting better simulation results if we tried to make this like the real economy by changing those slopes and intercepts for the savings and investment assumptions to make them both more inelastic. But we're not going to do that in this class, because that's way beyond the pale of what this model, that's way beyond what I have the right to expect you to know, I should say. So here's some conclusions that we've achieved. This demonstrates that crowding out, and the same solution to crowding out that was made evident in our use of the aggregate supply, aggregate demand model, when combined with our loanable funds model, when they reduced two comparative statics models. So the crowding out that is represented in the text, I didn't do that so much in the lecture, is still represented in these simulation models. And these simulation models show you how powerful monetary policy can be, And it shows how monetary policy in the short run can be used to override the crowding out effects of large budget deficits, completely override it, and push interest rates to very low levels, which at the time this video was being recorded was the state of affairs in the United States. We were running a budget deficit in the fiscal year 2020 of more than $1 trillion. We had high credit supply growth rates because the Federal Reserve was running effectively a very expansionary policy, pushing the structure of interest rates at the low end down close to 2%, and the entire yield spectrum of interest rates down low. But our simulation model that we have still has a limitation. We don't have an aggregate supply curve built into it. The original model is not the aggregate supply, aggregate demand model. It's the old Keynesian cross model. And wouldn't it be nice if we could add one more extension to this to put an aggregate supply curve, because currently this model can produce only nominal income. It can't produce inflation without that aggregate supply curve. I've experimented with doing that. It wouldn't be all that hard to do, except you have to have kind of a perfect functional fit that gives you that aggregate supply curve with the with the flat line that kind of slopes sharply up at the end. And I really haven't had time to figure out how to do that. But that would demonstrate at some point how these kinds of stimuli would eventually result in inflation, and because of inflationary expectation, even more inflation beyond that. But Macrosim 2 isn't built that way so far. We need to have an aggregate supply curve built in. But if we had one, what would it say in 2019 or 20 if it did have one built in? Well, that's it altogether. No more videos coming on Macrosim 1 and 2. I do encourage you to pull down the Python models and play around with them, maybe in the summer or something, if you want to see a little bit more about what they seem to imply and you want to play with the elasticities. But aside from that, I think we're done with this.